Next topic we are going to study is zeros of a polynomial px. So what it says that the value of a variable x at which the polynomial px is becoming 0. So we have been given a polynomial px. We are interested in finding out those values of x where this polynomial is becoming 0. Let us take an example that we have been given a polynomial px defined as x plus 2. We are interested in finding out those values of x where this is becoming 0, this polynomial x plus 2 becoming 0. So it is just like solving this equation x plus 2 equal to 0. If to find those values of x where it is 0, so we find out that x equal to minus 2 is a value of the variable x where this px is becoming 0. So this value x equal to minus 2, we say that this is a 0 of polynomial px. X equal to minus 2 is a value of variable where this px is becoming 0. Right? Let us take another example. Suppose we have px is equal to x square plus 3x plus 2. This may be factorized as x plus 2 and x plus 1. Now we have to find out the value of zeros, whether it is becoming 0 or not. Yes, of course, it is becoming 0 at x equal to minus 1 and minus 2. So we say that for this polynomial px, we have two zeros. Number one zero is minus 1 and second zero is minus 2. So basically, it is just solving a quadratic equation x square plus 3x plus 2, or in this case a linear equation x plus 2. So basically what we are doing is we are equating the polynomial equal to 0 and then finding out the values of x where this is becoming 0. So those solution of the equations will be the zeros of the polynomial. Okay, so in simple words, the value of the variable where the polynomial is becoming 0, right? That is called the zero of a polynomial. Now a polynomial px may have single zero, only one zero, just like in this case x plus 2. It may have two zeros, like the second example minus 1, minus 2. It may have three zeros if your polynomial is cubic, means of degree 3. And also you may have a polynomial which do not have any zero. For example, let us take third example which says, example number 3, we have, let us say px is equal to x square plus 1. Now if you look at closely, x square is positive, plus 1 is again positive, positive plus positive is positive. So you won't find any value of x where this px is becoming 0. That means x square plus 1 equal to 0 does not have any solution. Does not have any solution. Means you won't find any value of x where this x square plus 1 is becoming 0. So in this case, this polynomial has no zeros. Right? So you might come up with this, that a polynomial px may have 5 zeros, it may have 4 zeros, it may have 3 zeros, 2 zeros, 1 zero, or no zeros, right? It depends on the definition of the polynomial, how the polynomial is defined. Okay, so this is regarding zeros of polynomial. Now graphically, if we have to see this, let us talk about this polynomial px is equal to x plus 2. Okay, our first example, right? As you know that if you compare this, y is equal to mx plus c. Okay, here the slope value is 1 and this constant is 2, which is your y-intercept. So graphically it will look like, let us say like this. Okay, this value is 2. This is your x-axis, this is your x-axis, this is your y-axis, right? So at this value x equal to minus 2, this polynomial is becoming 0. This is the root of the equation x plus 2 equal to 0, right? So wherever the graph of polynomial intersecting the x-axis, that particular point is your 0. Okay, and if the polynomial is intersecting at only one point, you will have 1 0. If the polynomial is intersecting the x-axis at multiple points, you have those many of zeros. right? We will look this in our very next topic, which is the types of polynomials. Okay, so next is types of polynomials. In our previous lecture, we ended up with defining the order of the polynomial, right? And we started with the order 0, right? So if any polynomial is of order 0, that polynomial is called a constant polynomial, right? So this px, any polynomial, let us say, is equal to 3. Here the order of the order of this polynomial is 0, sorry, right? So this is called a constant polynomial because its value will always remain 3 no matter what the value of the variable is, because it is independent of the variable. There is no variable as such, right? Graphically, if we have to represent this, we can say that if these are our x-axis, this is your value of the polynomial px on y-axis, so this value will always remain 3. It is constant, okay, no matter what is the value of x. And also, since this px equal to 3 is not intersecting the x-axis, that means it does not have any 0. So we may write here as it has no zeros. Okay. So a constant polynomial is of order, let me write order here, of order 0. Okay. Now, next order in any polynomial comes with order 1. Okay. So a polynomial of order 1 is called as a linear polynomial. Generally, we represent a linear polynomial like with this ax plus b, where a and b are constant. As you can see here, that value of the order in this is this one. Okay. Graphically, if we have to represent this, suppose we have x-axis, this is your px. So it will look like a straight line, because if you compare this with the equation of a straight line y equal to mx plus b, so that equation of a straight line is also a linear polynomial because the order of that variable x is 1. Okay, so a linear polynomial is nothing but a straight line which is intersecting at a point where this is where it is becoming 0. You can find out the point also for this polynomial. That means x equal to minus b upon a is a point where this polynomial is intersecting the x-axis. And what is this minus b upon a? This is 1 0 of px. Okay, so we have here 1 0. Fine. Next comes a quadratic polynomial. So any quadratic polynomial will have order as 2, and generally we represent this by ax square plus bx plus c, where a, b and c are constants, and the shape of this quadratic polynomial, we call this shape as a parabola. A parabola. Fine. Now there are two possibilities. This parabola could be upwards like this, or we may have a downward parabola like this. This is called upward parabola. This is called downward parabola. Now, depending upon this value of a, the shape of a parabola comes. So, if this a is positive, we say the parabola is upwards like this, and this downward shape comes with a negative value of a, right? So if you have been given any polynomial px, you look at the coefficient of x square. If it is positive, we end up with an upward parabola, and if it is negative, we ended up with a downward parabola, right? So now we talk about the zeros of a quadratic polynomial, right? Let us see that you have been given a polynomial which is intersecting the x-axis at two different points. This is point number 1, this is point number 2. Okay, here we have two zeros. whatever is the value of this. Okay, since this it is intersecting at x-axis at two different points, so we have two different zeros. Okay, you might have a parabola which is not intersecting at all, like this. So in this case, we ended up with no zeros, okay, because it is not intersecting the x-axis at all. So here we do not have any zeros, so we say that this quadratic polynomial does not have any zeros, right? It is just like x square plus 1, like we did in the previous slide, that this is not, this polynomial x square plus 1 does not have any zeros. Okay, so it is not intersecting the x-axis at all. There are no point of intersection of the px with the x-axis. Okay, but important point here is that you won't find any quadratic polynomial with a single zero. Means since the shape of this polynomial px or quadratic polynomial is like this, that it has to come back. If it is going downwards, so it has to come back to its upward direction, or vice versa, that if it is going upwards, then it has to come back in this direction, right? Okay, so if it has to come back to its original direction, that original position, that means it has to intersect either at least either twice, or it won't intersect at all. You won't find any parabola which is intersecting the x-axis at a single point, because it has to come back. So if it is intersecting the x-axis at a single point, that means it has to intersect at other point also. So we ended up with two zeros, right? But if it is not intersecting the x-axis, like this, it is in the air, that means it won't have the other zero also, right? So we have a statement here, very important statement, that you may write down this as a note, that a quadratic polynomial either has, or you may write, sorry, not either, you can have a polynomial, quadratic polynomial has maximum two zeros. Simple. Maximum two zeros, right? And not one zero, not three zero. It may either have a zero polynomial, that is, you may note down this also, that is, it has either zero number of zeros, or simply no zeros, or two zeros, right? Only in case of quadratic polynomial, right? So a quadratic polynomial have maximum two zeros if you are talking about a real number of zeros. Okay, x equal to this. We are not talking about complex numbers, right? We will come do this afterwards. Last polynomial, or the category of a polynomial, is your cubic polynomial. So as the name suggests, cubic means any polynomial px which is cubic in nature, or which is having order as 3. So any general cubic polynomial is represented by this ax square plus ax cube plus bx square plus cx plus d, right? Here we have order as 3, and uh, you may have order as 3, yes. It is also having some complication as far as its zeros are concerned, because a cubic polynomial will be like this, shape of a cubic polynomial will be like this. Here we have only one zero. A cubic polynomial may have this shape, means here we have three zeros, right? So there are two possibilities, just like in case of quadratic polynomial. For a quadratic, we have either zero zeros, no zeros, or we ended up with two zeros. Similarly, on the same line, we have for a cubic polynomial, either it will have only a single zero, like this, or it will have three zeros, right? The shape of this cubic polynomial, it determines that it won't have any even number of zeros. Means it is intersecting like this at this point, then it is going downwards at this point. So since shape of this cubic polynomial is such that it has to come back in this direction, so it has to intersect like this at the third point. Or it is not coming downward, so it is not coming upwards. Okay, so it is just going like this and going upwards to plus infinity. So here we have only one zeros. So we can also make a note for a cubic polynomial that any cubic polynomial will have maximum three zeros. That is, it has either zeros, it has either one zero or it will have three zeros. There are no odd number of zeros allowed for a cubic polynomial, right? So in simple words, in all these types of polynomials, if someone is asking how many how many zeros are possible for these polynomials, so you can say that maximum number of zeros possible for a constant is zero. It does not have any zero because it is not intersecting the x-axis. For a linear polynomial, we have only one zero because a straight line will always intersect the x-axis like this. Okay, if I show you at this laser that it is intersecting at a single point minus b upon a, and it will always intersect at this point minus b upon a. Depending upon the value of b upon a, you will have different values of zeros, but yes, for sure it will intersect at only single point, and it will intersect. Okay, so you will always have one zero for a linear polynomial, but for quadratic polynomial it is not the case, that you will have either maximum number of zeros as 2 or you will have no zeros, right? Same is for cubic polynomial, that it will always intersect at least once on the x-axis like this, right? It may intersect at three different points or it will intersect at a single point. You won't find any only 2 point of intersection, right? So we have for a cubic polynomial maximum of zeros possible here are 3. Okay, you may write down as 3 zeros maximum number. Here we have 2 zeros maximum numbers. Here we have 1 0 and here we do not have any 0, right? So as you can see here, since order of a cubic polynomial is also 3, here order is also 3. So this maximum number of zeros and the order, it is matching. So just by looking at the order of a polynomial, we can determine the maximum number of zeros possible for any polynomial, not just these cubic, quadratic, linear, or constant. If you have been given any polynomial px of, let us say, order 6, so you can definitely say this, that it will have maximum number of zeros as 6. Fine. So this is about types of polynomials. In the next video, we will see the algebra of polynomials, how to add polynomials, how to subtract, multiply, and divide two polynomials, and we will see what happened to the order of the polynomial. Thank you.